Hello there, Gregory Carlson here as we talk about section 1.8, which is all about absolute value. Now, when you're solving an absolute value equation with an equals sign, you're almost always going to get two answers. So for example, if I have the absolute value of x, with the signs around the x, is equal to 3, I'm going to get two answers. Obviously 3 is an answer because the absolute value of 3 is 3, but also the absolute value of negative 3 is 3. Because remember, absolute value always produces a positive number because it is measuring distance. So the answers would be negative 3 or 3. So if you had the absolute value of x is equal to, say, 12, that's really easy to solve. It's just 12 and negative 12. Or I should say 12 or negative 12, because it can be either one. What if it's a little more complicated, like the absolute value of 2x minus 4 is equal to 10? Now this first page of notes is going to be all the stuff you kind of need to memorize about absolute value, and the second page will do some practice problems. If I have the absolute value of 2x minus 4 is equal to 10, you just write the equation twice. Once without the absolute value signs, and again with a negative in front of whatever number is over here. So it's kind of like how we got rid of the signs and put x is 12, x is negative 12. You get rid of the signs and put 2x minus 4 is 10, 2x minus 4 is negative 10, and then you just solve those equations one at a time. So add 4, 2x equals 14, divide by 2, divide by 2. Our first answer is x equals 7. Add 4, 2x is negative 6, divide by 2, x equals negative 3. There are two answers. Again, this is almost always going to give you two answers, unless you have a 0 right here, in which case it's not going to give you two answers, you'll just get one. So, as always, let's check our answers to make sure they work. Take the 7. 2 times 7 is 14. 14 minus 4 is 10. Absolute value of 10 is 10. So that works, and I'll put a little smiley face beside it because we checked to make sure that it worked. Now let's check negative 3. 2 times negative 3 is negative 6. Negative 6 take away 4 is negative 10. And the absolute value of negative 10 is positive 10. So the absolute value of negative 10 is equal to positive 10, and so we get a smiley face by that one too, because we checked both of our answers and got them both right. So that's how to solve an absolute value equation. You drop the absolute value signs, write whatever it is equals the positive number, whatever it is equals the negative number. Now, by the way, when we're doing this, we should always try to isolate the absolute value signs first. Similar to when we were solving the square root equations, you should isolate the square root first. In this case, you should isolate the absolute value. So what do we do if we have absolute value on both sides? Well, you actually get four equations, and those equations are 2x minus 5 equals 3x minus 4. There's your first one. You would also get 2x minus 5 is equal to negative 3x minus 4. Then you would get negative 2x minus 5 equals 3x minus 4, and negative 2x minus 5 equals negative 3x minus 4. So those are the four equations, and do you see something that can help us out here? Take a look at those four equations, and what do you notice? Would you agree with me that these two are equivalent? Because if we just divided by negative 1, this minus sign would move over to the other side. They are equivalent. Also, these two are equivalent. Because if I divided this equation on both sides by negative 1, the negatives would cancel and I'd get the top equation. So even if we have absolute value on both sides, then we still only get two equations, as I've shown you here. Here's your first equation with just no absolute value signs. And you can do the second equation by writing 2x minus 5, or whatever this side is, and then the negative in front of the entire piece over here. So you will have to do the distributive property with the negative sign. Solve these like you normally would, and check your answers, and you will be done. So let's move on to inequalities. Now we're going to talk about or and again, like we did with solving those quadratics. If the absolute value of the x is bigger than a number. If it's bigger than 2x plus 1, absolute value is bigger than. X is bigger than. Absolute value of x minus x is absolute value of x minus 7 is bigger than. If that's the case, it's an OR problem. So if the x is greater than the number, that's an OR problem. And so you would solve it like this. Let's solve the equation absolute value of 3x plus 4 is greater than or equal to 13. Okay, let's solve this. If it's an OR problem, here's the procedure. You write two equations. The first one, you just write the equation without any absolute value signs. The second equation, you flip the sign, and put a negative there. So it's 3x plus 4 is greater than or equal to positive 13. 3x plus 4 is less than or equal to negative 13. That's just a procedure you need to memorize. So now let's solve these. Minus 4, minus 4. 3x is greater than or equal to 10. Divide by 3, divide by 3. Remember that if you divide by a negative, you need to flip the sign, but we're okay right here. So x is bigger than or equal to 10 over 3. And let's solve this one. Minus 4, minus 4. 3x is less than or equal to negative 17, which is negative 13 minus 4. Divide by 3, divide by 3. So the second equation would be x is less than or equal to negative 17 over 3. Notice, by the way, that these two aren't the same numbers. It's not 10 over 3 and negative 10 over 3. So they're not always going to be the same. So you need to go ahead and solve both of them very carefully. Now, because it's an OR problem, any of these values can be the answer. So you write your answers like this. We're less than or equal to negative 17 over 3. Bracket, because we're equal. Or here I have 10 divided by 3, which in fact should be a 9. So I apologize. I made a mistake. This should be a 9 right here. I hope you caught that. And you were wondering, oh, that crazy Mr. Carlson, why did he put a 10 there? 13 minus 4 is 9. So this entire thing should be just 3. So that makes life a little easier for us. Sorry about that. So we're bigger than 3, so that should be 3 to infinity. There's your answer. So notice with an OR problem, we're going to get two sets and the union symbol in between them. And that's the procedure for solving them. So if it is x is bigger than, or the absolute value with x is bigger than, you break it into two equations, solve them both, and both of those are your answers in interval notation. What if it's less than? That means it's an AND problem, and our x is kind of constrained. So imagine we had 2x plus 2, the absolute value of that is less than or equal to 10. That means our values are kind of constrained. X can't get too big without getting too big on either side of 10. And so here's a clever way of doing it in a slightly easier way. Start by taking this number and slap a negative, like that. Then do a less than or equal to, because of that. If this was just less than, you'd put just less than there. Now you put the middle part, and then you put the positive number. And that's the procedure for doing an AND problem. It's always the same. Take the negative of this, less than or equal to the absolute value, less than or equal to the 10. Let's solve this. So minus 2, minus 2, minus 2. So negative 12 is less than or equal to negative 2x is less than or equal to 8. Remember, when we have two inequalities, you need to do it to all three pieces. And then finally, divide by negative 2, divide by negative 2, divide by negative 2. So we divided by a negative, so we need to flip all the signs. So negative 12 over negative 2 is 6. Flip the sign, you get x. Flip the sign, you get negative 4. So that's kind of hard to read. 6 is bigger than x is bigger than negative 4. So let's write that in reverse. Let's write it as negative 4 is less than x is less than 6. Take a minute to convince yourself that that's true, that these two are equivalent. Do you see that negative 4 is less than x is the same as negative 4 is less than x? Now here's the nice part about doing it this way. We're ready to go straight to interval notation. Done. Straight to interval notation. Remember on that x squared problem where we had to figure out the overlap and we had to draw the two number lines over each other and had to do the overlap? That was really annoying, and so that's why it's nice to just write this in one compound inequality. That's what this is called, because then you can just get your answer straight to interval notation. Because of the equals sign, we put brackets. If it had been no equals sign, it would have been parentheses. Let's take a break in 1 second and do some practice problems. There are a few trick questions to be on the lookout for. Check this one out. The absolute value of 3x plus 2 equals negative 8. That has no solution because absolute value of all of this is always going to be positive. So it doesn't make sense for this. This equation doesn't make sense because this is always positive, so it's never going to be negative, so it has no solution, 0 with the line through it, or the not symbol. How about this one? Absolute value of 2x minus 1 is less than negative 2. Well, absolute value can't be negative, and so definitely it can't be less than a negative, so this also has no solution. But what about this third one? The absolute value of 2x minus 1 is greater than negative 10. This is always equal to 0, or it's positive, because it's absolute value. And so that's always bigger than a negative number, so that has an infinite number of solutions, all real numbers. And if you remember, that's negative infinity to infinity for all real numbers. So keep on the lookout for these kind of trick questions. If we're equal to a negative, no solution. Less than a negative, no solution. But if we're bigger than a negative, it's the opposite of that. We have all solutions, and so that's just something to keep an eye out for. There is a lot to remember on this page, and many students don't do so well because they don't take the time to memorize the procedures for these. Please make sure you know how to solve each one of these problems, and we will do some practice ones in part 2, and I will see you there.